Good morning, children. While catching a fast-moving cricket ball, a fielder in the ground gradually pulls his hands backwards with the moving ball. Why is that? If a fast-moving ball hits you, it really hurts. But if a slow-moving ball hits you, you don't feel much, right? If you throw a stone at a wall, the wall wouldn't get damaged, right? But if someone fires a shot at the wall, it would make a hole in the wall. Means a small fast moving bullet applied more force than the bigger stone. So we can say the impact produced by the objects depend on both the mass and the velocity. Similarly, we need to put more force to make a object go faster. Like if you hit a ball harder, it will go faster. And if that ball is heavier, you would have to put more force. So, there must be a quantity that combines mass and velocity in such cases. You know, Newton called that quantity momentum. So, momentum is the product of mass and velocity. And the momentum of an object has the same direction as the velocity. The unit of momentum is unit of mass multiplied by unit of velocity. For example, mass is in kgs, velocity is in meter per second. So we can say unit of momentum is kg meter per second. So now you can understand a fast moving bullet has huge momentum because of its velocity is very high. If you push an object and it moves, then it means it actually gains some momentum. Take for example, if you push a car with dead battery or bad starter, it gains some momentum and finally it starts. Now, if you give a sudden push to a car with dead battery, will it start? It wouldn't start. If you keep pushing it gradually, it will gain speed. That is, it will accelerate and then engine will start. What does it mean? It means that the change of momentum of the car not only depends on how much force is applied, but also on how long the force worked. That is, time should also be taken into consideration. And this is what Newton said in his second law of motion. The rate of change of momentum of an object is proportional to the applied unbalanced force and it is in the direction of force. Rate of change means we have to consider the time factor also. Say something with mass m was moving with velocity u. Now you give it a push and its velocity increases to v. So, u is the initial velocity and v is the final velocity. So, what is the change in the momentum? The final momentum would be mass multiplied by final velocity, that is mv. And initial momentum would be mu. Now say force F was applied throughout the time t. So, the rate of change of momentum is equal to final momentum minus initial momentum divided by time. This becomes mv minus mu divided by t. And you know this is proportional to the applied force. As we know, we need a constant of proportionality to get rid of the proportion sign. So we can say F is equal to K m multiplied by v minus u divided by t. Here k is that constant. Now what is v minus u by t? If you remember, actually it is rate of change in velocity and this is known as acceleration. So F is equal to k m a, where a is the acceleration. The unit of force is such chosen that the value of constant k becomes 1. One unit of force is defined as the amount that produces an acceleration of 1 meter per second square applied on 1 kg of mass. So, 1 unit of force is equal to K multiplied by 1 kg multiplied by 1 meter per second square. So, K is equal to 1. Thus, the value of K becomes 1 and we get F is equal to mass into acceleration. Now that you understand Newton's second law of motion, let us see why fielders pull their hand downwards or backwards while catching the ball. This is done to increase the time in which velocity is reduced to zero. So, the rate of change in momentum is decreased, hence lesser force needs to be applied to stop the ball. On the other hand, if the fielder tries to catch the ball suddenly, then what happens? The high velocity of ball decreases zero in a very short time. So, if we see the formula, the change of momentum is very large and large force will be required to hold the catch, and this may also hurt the fielder. So now you know Newton's second law of motion, which says the rate of change of momentum of an object is proportional to the applied unbalanced force and it is in the direction of the force.